Hello. In this video, I'm going to show a simple task using the mask RCNN to detect the Twitter following buttons. This is an object detection task, and the images looks like this, which is just the Twitter following page screenshots. The target is to detect the positions of the following buttons here, looks like this. I've got 5 images here, and I used the images 1 to 4 for the training and validation, and the image 5 for the testing. First, I feel 4 images are too small a data set, so I cut those 4 images into smaller pieces, looks like this. And I've got around 50 of them, and I separate those small images into 2 datasets, the training and validation. In order to detect those buttons, we also need the annotation files, looks like this, which are just the positions of those buttons. In order to get it, I use the tool called Vio. Here is the online version of it. You can check it out. After the image and the annotations are ready, we are ready to train our model. We load our libraries and modules and set the root directory and the project directory, and set the directory for the pre-trained weights. Here we define a configuration class for the training process. You can overwrite the parameters in the class. Mask RCNN using datasets class as input, so we need to define a button dataset class. The function node buttons imports the images and the annotations. The function node mask creates masks based on the bounding boxes. The function image reference returns the path of the image. Here we create training dataset and validation dataset. Here is one example showing how mask works. It's just to filter out the object that we want to detect. Here we create the model in the training mode with configurations we just defined, and we select the pre-trained weights. Our training processes are divided into 2 stages. One stage only train the weights in the head layer. Second stage, trained weights in all layers. For simplicity, I used a very small number of epochs. This might take a while. After the training, we recreate a model in the inference mode, and we use the configuration in the inference configuration class. And we use the last trained weights and load those last trained weights. Here we are ready to using our model to test on our testing images. We load our image, and here is the image. Then we use our model to detect it. And we visualize the result. And we can see our model correctly detect the positions of the buttons. And we print out the bounding box positions. Thank you for watching. Bye-bye.